Video we are going to start the unit 4, which is about the grinding process, gear manufacturing process and surface finishing process. Very important unit. Mostly theoretical portions are there, so it is very important to understand the basic concepts of these processes. So let's start with the unit 4. The first process is the grinding process. So in the grinding process, the main cutting tool which is used, for example, in case of turning facing, you had the single point cutting tool. For drilling, you had the drill bit. For milling, you had the milling cutter. Okay, so in grinding, the main cutting tool is this grinding wheel. This grinding wheel consists of several elements, and out of those elements, the important element is the grit or abrasive. So this grinding wheel mainly consists of number of grits which are bonded together with the help of some bonding agent in the form of a wheel. So when the sharp grits makes a contact with the workpiece surface, those grits acts as the cutting tool and removes the material from the workpiece surface. So there are some desirable properties of these grits or abrasives, which are they should have a sharp point, sharp cutting edges, they should have very high hot hardness, they should be chemically stable, and they should be wear resistive. What does these points means? They have very high hot hardness means the grits or abrasive does not lose their hardness at higher temperatures. ओके ऐसा नहीं होना चाहिए कि जो हीट जैसे यहाँ पे जनरेट होगा तो ग्रिट सॉफ्ट हो जाए, नहीं, ग्रिट सॉफ्ट हो गया तो ये जो वर्क पीस है ये ग्राइंडिंग व्हील को ही कट करना शुरू कर देगा, तो वो नहीं होना चाहिए. दूसरा, ग्रिट वियर रेसिस्टिव होना चाहिए, वो जल्दी वियर ऑफ नहीं होना चाहिए. ऑब्वियसली विद टाइम it will get wear off with number of cycles, number of passes, number of work pieces, and these grids should be chemically stable. Okay, so it is the definition of the grinding process. It is a material removal or material cutting process which engages an abrasive tool in the form of a wheel whose cutting elements are grains of abrasive material known as grit. These grits are characterized by sharp cutting points, high hot hardness, and chemical stability and wear resistance, as I have already discussed. These are held together. These grits are held together with the help of some suitable bonding material. Okay. So next is the contact of the grinding wheel with the workpiece surface. These are the grits. These makes a contact with the workpiece surface and removes the material layer by layer. With this, it gives us a very good surface finish product, very accurate product, and this grinding process is applicable to both hardened and unhardened, means soft or hard, both types of material can be easily machined with the help of grinding process. Okay, some of the applications of grinding are: grinding process is used to make the surface finishes. It can be used to cut the material, slit or part. It can be used to descaling. Descaling means to removing the layers of carbon or rust from the surface. It used to deburr the materials. Deburr means burr, fata burrs. During the facing process, you must have encountered with some burrs. जब आप फेसिंग करते हैं तो फेसिंग के दौरान जब आप फेस सरफेस को टच करोगे तो you will feel some small particles of the material on the face surface. Those are called as burrs. So when these burrs are make contact with the grinding wheel removes those burrs and makes the surface finish. So grinding can also be used to remove the material in a stock. It can be used to machine or finish the flat as well as cylindrical surfaces. This we will discuss later on the lecture. And the grinding of the tools, as you have already grounded one single point cutting tool as an experiment in your manufacturing machines. lab. Okay, so in grinding, the grids could have rake angle. They could have positive, they could have zero, they could have negative rake angle. As shown in this diagram, some of the grids has zero rake angle, some of the grids has negative rake angle, some of the grids has positive rake angle. So these grids could have negative, positive or zero rake angle as well. They have very low shear angle, low depth of cut and low feed rate. So during the grinding process, these three conditions should be low. The depth of cut should be very low, feed rate should be very low. Okay, on the other hand, the cutting speed should be very high. So the rotating speed of the grinding wheel should be very high for obtaining the good grounded surface. Interaction of the grit with the workpiece. These are the three possible ways in which this grit can make a contact with the workpiece surface. First is the shearing. If the area of the grit is larger, it will generate a plowing, and if it is operated at very slow speeds, then it could generate a rubbing process as well. Okay, so these are some questions. Please go through this. This is the diagram of the specific energy consumption in grinding process. As you can see that during the rubbing and the plowing, rubbing and plowing processes, the stock material removal is very less. On the other hand, the energy which is utilized in the grinding process will be very high. Okay, so this is clear from this diagram as well, this graph as well. During the rubbing and plowing processes, the specific energy utilized is very high. Okay, on the other hand, material removal rate is very low. Okay, so as the material removal rate gets increased in case of shearing operation, that is completed with very less specific energy required. Okay, so next concept is is known as G ratio. Okay, so during the grinding process, during any machining process, there are strong possibility that during that process some of the material from the cutting tools also gets removed. Same with the grinding process. When the grinding wheel makes a contact with the workpiece surfaces, it removes the material from the workpiece surfaces as well as during the contact of the workpiece with the grinding wheel, some of the grits which are present on the periphery of this grinding wheel may also get removed in this process. So there is removal of material from both the grinding wheel as well as from the workpiece surface. So this G ratio defines the ratio as the volume of stock removed from the workpiece surface divided by the volume of the wheel lost. Okay, so in conventional grinding, the G ratio is in the range of 20:1 to 80:1. Okay, so it is the ratio of the volume of stock removed from the workpiece surface divided by the volume removed from the wheel. Okay, which we have termed it as loss. Okay, so in this video we have discussed the basics of grinding process, the basic definitions, the desirable properties of the grids, and the G ratio of the grinding process. In the